Today I'm doing section 13.7, solving word problems involving quadratics. You'll be doing page 605, 1 through 13 all. Alright, so let's start with our first problem. We're really doing a lot of the same problems. They're just, now we have mathematics that involve quadratics. If the square of two consecutive integers are added to the result is 61. Find the integers. So, what do we call the first integer? If we don't know what it is, we call it x. And what do we call the second one? It's two consecutive, not even, not odd. So if it's consecutive, we call it x plus 1. Okay? So if the square of them are added, so we have to square the first one, x squared, and then we have to square the second one, x plus 1 squared, the quantity. The result is 61. There's my equal sign. Now, remember when we have x plus 1 squared, it does not mean x squared plus 1 squared. It means x plus 1 times x plus 1. So when I square that polynomial, I'm going to end up with an x squared plus, remember I squared the first one, it's x squared plus 2x plus 1 equals 61. We can add the 2, gives me the middle term. I can multiply the 2, middle term coefficient. I can multiply the last 2, it gives me the last one. Okay? So now we have to combine our like terms, set it equal to 0. I get 2x squared. Luckily it's all even, so we can divide out a common factor of 2. That would leave me with x squared. If I divide all terms by 2, I end up with x squared plus x minus 30. Okay? What multiplies to negative 30 and adds to 1? We do our x marks the spot, negative 30 and adds to 1. That would be a 6 and a negative 5. So I'm going to factor that to x plus 6 and x minus 5. Now remember, we set that, those are not the solutions. Remember, we have to set x plus 6 equal to 0, x minus 5 equals 0. Subtract the 6, so x equals negative 6. So add the 5. So x equals 5, and so we are left with negative 6 and 5. But that means that if this is negative 6, then negative 6 plus 1 would be negative 5. Or what happens if it's the positive number? If it's 5, then 5 plus 1 is 6. So we have 4 answers here that you really have to write. Negative 6, negative 5, I guess, and 5 comma 6. I guess you could do and or. Okay? Sorry. Okay. Leaving that up. Again, we're usually going to put it in the braces. Negative 6, negative 5, or 5 comma 6. Okay? All right, question number 2. The area of the rectangle is 30 units less than, that word than, there's my minus sign. So we've got the area of a triangle. Find the height of the triangle. Okay, so let's take this and put it into an equation. First thing we're going to do is area of a rectangle, okay? Take that area of a rectangle, and it's saying is, there's my equal sign, 30 less than, so this less than, let me go back here. Okay, so I'm going to just say, I'm going to just kind of sketch this out. Area of a rectangle is my equal sign. 30, we have less than, and with than, remember that that 30 has to move over here. And then we have area of a triangle goes over here, and my minus sign's in the middle. So area of a triangle. So basically, we have area of a rectangle is equal to the area of a triangle minus 30. Okay? So that's where we're getting that equation. Now, when I get my area of a rectangle, how are we going to get that? How do we get that? We end up using the formula length times width. How do I get the area of a triangle? Remember, it's 1/2 the base times the height. Okay? So we have to go over here. Now we're going to substitute. So x times x plus 4 is equal to 1/2. The base is 4. Or we can do it. It doesn't matter the order. I think I'm going to put the height first. 1/2 x times 4x plus 6 minus 30. Okay? I'm going to go back to PowerPoint because it's probably going to be neater. Substituting in. Just wanted to make sure they were doing it one step at a time. All right, now I'm ready to distribute. Oh, they didn't put their x there. They put it at the end. Okay, so here we go. So when I distribute here, I'm going to end up with an x squared plus 4x. And then when I distribute, right, x squared plus 4x. Now, when I distribute, remember, I'm able to do some cross-canceling. So I'm left with a 2x. And then when I distribute here, I'm left with a 3. And then we're multiplying that whole thing times x minus 30. Which, that would simplify to 2x squared plus 3x minus 30. Okay, going back to my PowerPoint. So I'm going to probably distribute that x in. There we go. Now we set it equal to 0. I'm going to move my x squareds, everything to the right, because my bigger x squared is on the right side. So I'm subtracting x squared. I'm subtracting 4x. So now I'm left with x squared minus x minus 30. So what multiplies to negative 30, pretty close to what we did last time, a negative 1. So that would be a negative 6 and 5. So it would be x plus 5, x minus 6. Set both equal to 0, and x is equal to negative 5, or x is equal to 6. Now, x cannot equal both of those. And because we are dealing with area, we really have to eliminate one of those. So the one that can't work is the negative, because area can't be negative. So my x is equal to 6, and now I have the ability to find the height of the triangle, okay, which is, it's this x, right? X is what represents the height. So the height is 6 units. Okay? That's question number 2. All right, the frame question. This one's tricky. You've never seen it. I kind of introduced it. I don't know if I ended up talking. Some classes we talked about it. You just got to do it a couple times. It looks really confusing, but once you get the hang of it, it becomes pretty formulaic. Okay, a picture frame measures 30 by 20. The picture inside the frame has an area of 416 square inches. Find the width of the frame. So, the first thing we're going to do is we're going to talk about what's unknown as the width of the frame. We'll call that x. So, but it is safe to say that all the way around it is the same measurement. We don't know what it is, but it's x. Okay? We can say that that's x, this is x, and this is x. So the picture's length, the actual picture that's inside, we don't know the length, but what we do know is that the frame's length is 30, and we have a measurement right here. From here to here is x, and from here to here is x. And if the whole thing is 30, and then these two parts are x, then we can call that the whole, which is 30, minus these two x's. Okay? So what we're talking about is this line here. The length of the picture is the whole of 30 minus the two x's. And then we can figure out the width as well, because the width, the whole width of the frame is 20. So we can take the 20, and remember, you're going to also do another 2 minus 2x's. So it's 20 minus 2x. Okay? Now we're going to use our area formula. The picture inside the frame has the area. So we now know what the length is. We have a temporary name for the length and a temporary name for the width. And we have the area. So let's set up an area problem for a rectangle. Length times width equals area. So I substitute in. My length is 30 minus 2x. My width times the quantity of 20 minus 2x is equal to 416. We're going to do our double distributing. 30 times 20 is 600. First, outside, inside, last. Double distribute. To get my middle term, remember, I get that becomes a negative 40x. My outside, and my inside becomes a negative 60x, and that's how we get the negative 100x. And then I get plus 4x squared. I'm going to subtract my 416, and I am left with 184. Now, I do know that all three of these are even numbers, so I know it's at least divisible by 2. I know 4 and 100 is divisible by 4, but is 184 divisible by, I think it's also divisible by 4. So I'm going to try dividing all 3 by 4. And then I get x squared minus 25x plus 46. Looks ugly, but not necessarily, because there aren't that many factors for 46. That should be a 25. So what multiplies to 46? The only factor I know is 2. So 2 and 23. That works. So I'm setting it up. X minus 2, x minus 23 equals 0. So x equals 2 and x equals 23. Now you're going to have to really make sense of this. If I substitute in 23, because both the width can't be both answers. So in this case, it's a little trickier because one's not negative. But once you substitute in, if I substitute in here, we get a reasonable answer. 30 minus 4 is 26, right? But if I substitute in the 23, 2 times 23, that would be 30 minus 46. That would give me negative 16, and a picture length can't be negative 16. So it can't be that. It has to be the 2. And so I substitute 2 in, and I get 26 units, or 26 inches for the length, and 20 minus 2 times 2. 20 minus 4 is 16. And so I'm left with x equals 23. We know that it doesn't work, so my answer is it has to be the frame width. The question is, always go back, find the width of the frame. We have the ability to find the length and the width, and we need to figure out, substitute in, so that we can figure out which is the bad answer. But the question is, what is the width of the frame? We always go back. Okay. Hypotenuse of a right triangle is 20 inches. One leg of the right triangle is 4 inches longer than the other. Find the lengths of both legs. Okay, they're mentioning hypotenuse, side length. Clearly, we have to use something called the Pythagorean theorem whenever we're looking for a missing side length of a triangle. So I've got a triangle, which is, I'm going to draw it, and I'm going to label it. My hypotenuse is 20. That's the longest side, opposite the right angle. One of the legs is 4 inches longer than the other. I'm naming that the bigger side, x plus 4. The bigger side is x plus 4. That means the one they give us less information on is the smaller side, so we call it x. And this bigger side will be x plus 4. So now I'm substituting in x squared plus the quantity of x plus 4 squared equals 20 squared. Remember, when we square the binomial, we're going to get x squared plus 4 plus 8x plus 16. Okay, remember this really means x plus 4 times x plus 4. Okay, I'm subtracting 400, and I'm going to divide both sides by 2. And I get x squared plus 4x plus 192. Now, looking for factoring parts, okay? It's not that far apart, so there has to be 4 digits apart. I mean, they have to add or subtract. I'm going to try, and it's 192. I'm going to try, like 14 squared is 196. So I'm going somewhere around there. That's just giving me a ballpark. It's got to be some numbers close to there. I'm going to try, how about 12? So if I divide 12, let me see. 192 divided by 12. Oh, 16. 16 and 12 add to 4, or subtract to 4. So that's perfect, I guess. I was going to try 12. I was going to try 14. So 12 times 16 worked, and so my 16 has to be positive and my 12 is negative. So we have x minus 12 and x plus 16. Okay. And then we get x is equal to negative 16 or x is equal to positive 12. So going back, and it says find the lengths of both legs this time. So one leg is 12 units, or 12 inches, and then the other one is 12 plus 4, so that would be 16 inches. The larger leg is 16 inches, 12 inches. We're done. All right. So they don't do x marks the spot. They were just finding factoring pairs, so. All right, find the dimensions of a rectangle whose perimeter is 30 inches long. So I'm always drawing. There's perimeter. I'm labeling. P equals 38. Area equals 84. Okay? Find the dimensions of a rectangle whose perimeter is 38 inches and whose area is 84. Okay, here's what we're going to do. If the perimeter is 38 and the area, we're going to create a diagonal. Okay? And we know that if the whole rectangle, the perimeter, each side, side plus side plus side plus side, okay, we know that if the whole thing equals 38, then half of it, just the two sides, let's just call this side x, and we know that this top side, we know that half the perimeter has to be half of 38, right? So if I create that diagonal, I know that this side plus this side has to equal 19 inches, because that's half the perimeter. Okay, if we call the first side x, and we know that the whole two sides equals 19, can't we call this the whole 19 minus the x? Okay, we're calling it 19 minus x. So now we have units. Okay, we have units that we can use for our length and our width. We have a temporary name. So again, I'm going back to my area formula, length times width equals area, and I'm substituting in x times 19 minus x. And now I'm going to subtract 84. Or actually, I'm going to subtract the x squared. I'm going to add x squared because I want to make it positive. And I'm subtracting 19. And then we end up with, I'm thinking 84 is a multiplication table of the 12, so I think 12 and 7. It would have to be negative 12, negative 7. And this is going to be one of those trickier ones because they're both going to be positive. So my solution is x equals 7, x equals 12. And so now I'm going to substitute in. I have to substitute in and figure out which one works. So if x can't be both, because if x is 7, that works, and it makes this 12 and this 7, right? But if x is 12, it makes this side equal to 7. If x is 12, and it makes the shorter side bigger. So that is the one that doesn't make sense. All right? So now we have 7 inches and 12 inches. Okay, so it has to be the 7, and so I substitute 19 minus 7. All right, last question. A boat travels 12 miles upstream. Means, talking about a boat, miles, speed, hours, we're going to have to use our formula, distance equals rate times time. A boat travels 12 miles upstream. Sorry. And back. If the rate of the current is 2 miles per hour and the whole trip took 3 1/5 hours, find the speed of the boat in still water. So our unknown is our speed. We'll call that R for rate. I like to do boxes. So I'm comparing a boat that travels 12 miles upstream and back again. So I'm going to just draw it really quick. Okay, here's my boat. It's doing this. Upstream and back. What does that say about it? It says that our distance is the same. I go 12 miles up and 12 miles back. So when I label it rate times time, I'm going upstream and downstream. And I don't know why they set it up like this backwards, but it's fine. It doesn't matter. We're going 12 as my distance, and I know it's going to be for both. And it says the whole trip took 3.5 hours. Find the speed of the boat in, if the rate of the current is 2 miles per hour. So we have the rate of the boat and the rate of the current. So we can call this R going upstream. That's really, when you go upstream, you're going against the current. When you go downstream, you're going with the current. It's pushing you. It's pushing you down. So upstream would be R plus R minus 2, and the other one would be R plus 2. And we know our total time is 3 1/5 hours. Okay, so I see what they did. Okay. Now, this is what they're getting. They're just kind of going backwards. So it's just slightly different. I don't know that I would have set it up like this. Let's go back. Let's talk about, since our time is unknown, remember distance equals rate times time. I can also divide by rate. And so time is also always equivalent to a distance over rate. So that's where they're getting that 12 over r minus 2, and this is 12 over r plus 2. And so our equation is 3 1/5. We're going to convert that to my improper, and this is the column. So it's time 1 plus time 2 equals the total. That's basically what we're doing. Time 1 plus time 2 is equal to the total time. Okay? And how do we know what the time is? A time is always equal to distance over rate. So the equation is 12 over r minus 2 plus 12 over r plus 2 is equal to 16/5. Okay, we're going to go to that equation, and now we're going to solve it. I have to multiply by r minus 2 and r plus 2 and a 5. That's my least common denominator. Our least common denominator, r plus 2, r minus 2, and a 5. When I distribute here, the r minus 2 clears, and I'm left with 12 times 5 times r plus 2. When I distribute here, the r plus 2 clears, and I'm left with plus 12 times 5 times r minus 2. When I distribute here, the 5's cancel, and we're left with 6 times r plus 2 times r minus 2. Okay? Now, when you multiply that 12 and 5 each time, you're getting 60. Now, we're going to distribute everything. I like to multiply this first before I multiply it by the 16 because I know what that is in mental math. That's r squared minus 4. It's a difference of squares. And here I'm getting 60r plus 120 plus 60r minus 120. And now my 120s are going to cancel. So I'm left with 120r equals 16 r squared minus 64. Subtracting the 120r. Let's go back to PowerPoint, it's cleaner. Okay, I'm going to subtract the 120r. They're all divisible by 4. They might be divisible by 8. Yeah. So I get 2r squared minus 15r, and we have some lead coefficients. Now, this is the point where you can use quadratic formula, completing the square, or lead coefficient factoring. So if you're weaker in one, you kind of go to the other. What multiplies to 16 and adds to negative 15? How about negative 15? Negative 16 and 1. So I'm going to have x squared. Oh, I'm doing r squared, sorry. So r squared minus 15r minus 16. And so I get r plus 1 times r minus 16. But remember, we have to divide the 2. So I get 2r plus 1 times r minus 8. So r is equal to 8. And 2r plus 1 equals 0. Subtract 1. 2r equals negative 1 divided by 2. So r equals negative 1/2. Can speed be negative? No. So my r, go back to the original, has to be, oops. I'm just factoring it here. It has to be 8. And so there we have, it's 8 miles per hour. And that is our lesson.